If you are just joining today for the very first time, you are especially welcome. This is my second video on machine learning. The first one was on prediction using supervised machine learning, but today's video will be on unsupervised machine learning. I'm Nwobodo Maureen Amuche, and I'm currently working as a data science and business analytics intern at the Sparks Foundation. This is my second task as an intern, which I've completed successfully and would want to share with you. So for today, we'll be using unsupervised machine learning for our prediction. I'll be predicting optimal number of clusters using iris dataset. For this task, we'll be using k-means clustering. So we'll walk through some basic steps of k-means clustering. We know k-means clustering is one of the unsupervised algorithms where the available input data does not have a labeled response, unlike in supervised learning. K-means performs the division of objects into clusters that share similarities and are similar to the object belonging to another cluster. Yeah, basically this is what k-means clustering is. So for our setup, I'm going to import the important Python libraries. I will start by importing NumPy as MP for data computation, and then we'll import pandas as PD, yes, for our data manipulation. So after that, we're going to import matplotlib as PLT for our data visualization. Finally, to load our datasets, we'll import dataset from sklearn. Then after that, we're going to load our dataset. As the name of our dataset is iris, so we have iris equals dataset dot load underscore iris in brackets. Then we'll add data frame using pandas so that we can preview the feature name in our columns. After that, we'll preview the first 5 rows using iris.head. We can now see, if you delete it and put .head in brackets, then when you run it, you see the first 5 rows of our dataset. In my previous video, I talked about how to preview more than 5 rows, first 5 rows of the dataset, and how to preview the last 5 rows of your dataset. So the big question is, how do we find the optimal number of clusters for k-means, and how do we determine the actual value of k? The term k is a number. K-means clustering is a distance-based unsupervised clustering algorithm where data points that are close to each other are grouped in a given number of clusters or groups. So first of all, we assign a number to k by telling the system how many clusters it needs to create. In this case, our number of clusters is I, and if you look very well, you see our I is value range from 1 to 11. Then after that, we initialize our k, then randomly allocate k centroid points. Note that these centroid points can be anywhere as they are random points, but they are called centroid. So even though they are called centroid, initially they are not really the center point of this row. The next thing is to determine the distance between each of those randomly assigned centroids. And normally this calculation usually continues until the centroids get fixed. And for this, we have our maximum number of iterations as 300. Yes. So now, to be able to find the optimal number of clusters for k, we'll use what we call elbow method. Yes, we'll use elbow method. And elbow method is a graphical representation of finding the optimum k in a k-means clustering. It works by finding WCSS. What is WCSS? It's within cluster sum of square. That is the sum of square distance between points in a cluster and cluster centroid. So we'll do that by plotting the result that we've gotten earlier into a graph. And when we plot it, we'll label our plots. We'll label the x and the y axis. Then, yes, we label our x and y axis. So our x axis will be the number of clusters, while our y axis will be the WCSS. So this is the elbow graph. And if you look at it, if you're looking at expected, looking at like an elbow. Then if you look at the y-axis, we have the WCSS, that's the within cluster sum of square, then the x-axis is number of clusters. Also, when you look at our elbow graph, you see the point where the elbow gets from. Usually that point where the elbow gets from is called the elbow point. And from this graph, our elbow point is 3. If you look at it, it's between 2 and 4. So our elbow point is 3. And what we also notice that if we continue to increase the number of clusters after that elbow point, you see that it does not lead to any significant increase in the WCSS value. It just remains the same across board. No matter the number of clusters you are adding, it still remains the same. So after doing this, we now have to, since we've gotten our optimal number of clusters as 3, we'll apply k-means to the dataset. After that, we'll visualize the clusters on the first 2 columns using the scatter plot. So for every setosa clusters, we'll be giving it red color, give it different color so that the scatter plot will be very nice and easy to identify each one. So for the iris setosa, we gave it red color. For the iris versicolor, we gave it blue. Then for the iris virginica is green. Then finally, we close the centroid of the cluster and we are giving it a yellow color. So if you look at this scatter plot now, you see we have the blue, we have the red, the green, and the yellow. So the blue, as we said initially, is iris versicolor. Yes, and you can see the green color, which is iris virginica, then the red color too. Then most importantly, you see the yellow, the 3 yellow dots. Yes, that's our centroids. Remember the optimal number of k is 3. So that's why we have those 3 yellow points. And if you notice your position in this, you see that they are actually the centroid point because the distance between them and those other ones are really close. So this brings us to the very end of this task. Thank you so much for sticking with me through to the very end of this class.